So now with all of that, we can now load our items, we can add new items. The missing piece, of course, is that we remove items. I mean, we can remove items, but if we then reload, they will be there again because we only deleted them locally and not on our backend. That, of course, needs to change. And for that, we should go to this remove item method here in grocery list. And there we should send another HTTP request. Now it should, of course, be a delete request sent to a URL that's structured like this. And there's one special thing about that URL. It's the same URL as before, but at the end, we're pointing at a specific item in our Firebase database. A specific item by ID. So we have to include the ID of the item we want to delete in the URL, as you will see. Now for that here, we'll of course start by creating a URL. So we can copy this logic here from load items and add it to remove item. But now the URL must be adjusted. Instead of pointing at the overall shopping list, we want to point at a specific item in there. Because we don't want to delete the entire shopping list, but just one item in the shopping list. That's why we have to add another slash here after shopping list to target a specific item in there. It's like working with a folder structure. We want to dive into the shopping list folder and then target one specific folder by name, so by ID here. And now the ID here, of course, depends on the item that was selected. So here I want to inject a value into this string, which we can still do because this is a regular string. We can use this injection syntax about which you learned earlier and target an item by ID. And since these IDs are loaded from Firebase, this should work just fine. So with that, we're targeting a specific item. And that will be important because next we'll use the HTTP package to send a delete request to this URL. Now, just like get, delete doesn't need a lot of configuration. You could add a body technically, and you can set headers, but we don't need to do any of that. We don't need any extra metadata, and there also is no extra request body attached to this request. Instead, we just send a delete request to this URL, and Firebase will do the rest. I then, of course, also still want to update my local state to also remove that item from the local list. I don't want to fetch the entire list again, I just want to remove that one item which we deleted with this request from the list. Now we could add async await here to do that, but we actually don't even need to do that. I'm fine with not waiting for this before I update my local list, because the item can be deleted in the background. I don't need to wait for this request to finish to update my local list here. I had to wait when adding a new item because I needed that ID from the backend, but here for deleting, I don't need anything from the response. And therefore we can delete it instantly without waiting for the response. And if we don't add a wait here, we also won't wait for it. Instead, this request will be sent, but will not wait for the response. And therefore we should be good to go. With that, if I save that and reload, if I then wait for the data to load, Firebase was a bit slower here, and I then delete test, it's deleted locally, but also on the backend, as you can see here. It's highlighted in red, which is quite convenient, at least for a couple of seconds before it's then removed here. And if I now reload the app, we also won't see the test item here anymore. I mean, I have it here again, but if I delete this and maybe also chocolate, those items will be deleted also from the backend. And if I then reload, those items will, well, stay deleted. Now, of course, things could go wrong when deleting. I could again have an invalid URL or an error that's beyond my control. And in that case, we have a problem because now I can delete items locally, but they're not deleted on Firebase because something went wrong with the request. And for that reason, we then, for example, could be surprised if we visit the app again and the item is back. Therefore, we actually might want to check for whether this request succeeds and undo this deletion and maybe show an error message to the user if we fail to delete the item. For this, I will convert this to async so that I can await this, but I will actually update my list before sending the request so that we don't unnecessarily wait here, but I then take a look at my response here, and if my response status code is greater or equal than 400, so I know that something went wrong, I want to undo this deletion. And I can undo it by calling setState again, and now adding that item back to my list. Now with add, I would of course add it in a different place, therefore I might want to get the index first, which I can get by reaching out to my list, and there index of item. And then here, instead of add, we could use insert to add item at a specific index. And that's the same approach we used earlier in the course with a snack bar and the undo option we had there. Because insert is a method built into Dart that can be used on any list to add an item at a specific index in that list. So that will undo the deletion if we have an error. And of course, we also might want to show an error message here with a scaffold messenger and a snack bar, for example. But here, I'll keep it a bit simpler and not do that and just undo the operation. So now if I delete this, it will eventually come back, as you see, because the deletion fails. But of course, it might be better to also show an error message here, but since this is nothing new and not directly related to HTTP, I'll simply skip this step here, but it is of course something you could do. And with that, I'll of course now fix this URL again to make sure that deleting does not work again and we are using a valid URL.